Now, we are going to look at the quadratic formula, okay? But before we do that, we need to backtrack and grab something from a previous section, right? And that something is the imaginary unit I, okay? And I is the square root of -1, okay? So for any positive real number, b, the principal square root of -b is defined as follows. So here we have the square root of -b, all right? Before, we would say that this gives us an error, and it does. You can't take the square root of a negative number or an even number, right? You can of odd numbers, but not even numbers. Well, this is an even square root. You can't take the even root. You can take roots of even numbers. I said that. I might have said that wrong. Okay. So I'm taking the even root of a number. And so it's negative. So I've told you that you can't do it. But since now we know about this imaginary unit I, and it equals the square root of -1. So I can break this negative b into the square root of -1 times b. Okay, the square root of -1 equals I. So we just write I on the square root of b. Okay, that's how we're going to deal. Whoops. That's how we're going to deal with negative roots of even numbers. Negative roots of even numbers. Okay, so let's just work with these for just a second. Okay, this is even, it's a 2. We can write this as the square root of -1 times 49. Okay, and we know that the square root of -1 is I, and we know that the square root of positive 49 is 7. So we can write this as 7I. Okay. Same thing here. We can write this as -1 times 64. Okay. Square root of 64 is 8. Square root of -1 is I. I also could have something like the square root of -27. All right. 27 isn't going to give us just a whole number when we take the square root of it. Okay. It is not what I like to call pretty, as like 64 and 49 were, but we can still break this up into -1. And we can think of numbers of 27 that would help us out, like 9 and 3. 9 times 3 is 27. And 9 is a pretty number. It helps us out. So a couple of things happened. This is I. This is 3. Okay, so we have for our answer 3I on the square root of 3. Okay. And so we'll do one more. And this is something that you're going to see in the quadratic formula, and we're going to use it later. Okay. So say we have 25 minus 4 times 8. Okay. That's going to give us 25 minus 32. So that gives us the square root of -7. Okay. Which we can write as -1 times 7, the square root of -1 times 7. Well, the square root of -1 is I. And there's nothing that we can do to the square root of 7 to simplify it, right? It doesn't have any factors besides 1 and 7. So we just get I on the square root of 7. Okay. So this whole page is just for you to realize that we have something going on with our negative numbers when we're taking the even roots of them. Okay, now we don't have to write error, we can use I. Okay, and we're going to use this a lot in the quadratic formula. So here is the quadratic formula. Right here, I can use a bigger highlight. The solutions of a quadratic equation in standard form, ax squared plus bx plus c equals 0, are given by x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so our a's and our b's and our c's correlate to over here. All right, so there are coefficients on our equation. So let's do a few examples. All right, so x squared minus 2x plus 2 equals 0. It needs to be in standard form, so that means equal to 0. And you have ax squared plus bx plus c, so we're okay. Standard form. I'm going to say standard form, and I'm going to check. All right, and we have a, b, and c that we need to identify because those are the letters that are in our equation, in our formula, I mean. So the coefficient on our x squared term is 1. There's an understood 1 there. And then b is negative 2, c is 2. All right, so here's our equation. Our formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So now we're just going to plug in. All right. So we're going to do the opposite of whatever b is. All right. So I have negative, that's this negative 2 plus or minus the square root of b squared, so negative 2 squared minus 4 times a, which is 1, times c, which is 2, all over 2 times a, which is 1. Okay, so I've plugged all my numbers in. Now I'm just going to clean up. So I get 2 plus or minus square root. All right, negative 2 squared is 4. And then I have 4 times 1 times 2, which is 8. But I have this minus sign right here. So I have minus 8 and the square over 2. All right, keep going. X equals 2 plus or minus the square root of negative 4 all over 2. Right? So in my square root, I have a negative, right? So go over here for a second. The square root of negative 4 gives us, we can write this as negative 1 times 4, right? And the square root of 4 is 2. And the square root of negative 1 is I. Okay? So the purple 2i is going to go in place of the square root of negative 4. Okay? So I have x equals 2 plus or minus 2i over 2. Now, I have this over one number, right? Just 2. So I can split them up and I can say 2 over 2 plus or minus 2i over 2. And that's going to give me, well, 2 over 2 is 1. Plus or minus 2 over 2 again here is 1. So I'm just have 1 plus or minus I as my answer. Okay. This was over one number, so I can split it up. I can write it like this, and it'd be the same thing. It'd be equivalent. All right. So my answer is 1 plus or minus I. Okay. And I'm actually going to grab this and move it over here so I can work the next one. All right. Here's this one. I want to give you a second. So pause this and see if you can do it by yourself. All right. So you try. And then I'm going to write it out and see if you get it. Okay. Your first step is standard form. So equal to 0. So you're going to have 2x squared minus 6x plus 1 is equal to 0. Label your A's, B's, and C's. A is 2, B is -6, C is 1. And then you're going to plug those into your equation. So you have the opposite of B plus or minus B squared, so -6 squared, minus 4 times A times C, all over 2A, which is 2. Okay. Clean it up. You get 6 plus or minus, whoops, 6, -6 squared is 36 minus 8, all over 4. So x equals 6 plus or minus the square root of positive 28 over 4. All right, go over here to the side and see what we can do with the square root of 28. All right. So it's not something that's going to give us a whole number, right? But we do have the factors of 28 that could help us out. We have 7 and 4. Okay, the square root of 4 is 2, and we're going to leave with the 7. So when we write our next line, instead of writing the square root of 28, we're going to write 2 on the square root of 7. Okay, notice how this has nothing to do with I because we do not have a negative number under our root. Okay, 28 is positive, so we're okay. We don't have to worry about I's at all. We just simply simplified square root of 28. So we get x equals, change my color, x equals 6 plus or minus 2 on the square root of 7 over 4. Okay. So we have x equals 6 plus 2 on the square root of 7 over 4. Square root of 7 over 4. Or 6 minus 2 on the square root of 7 over 4. Okay, so we had plus or minus just like we did on our square root method. And so we split it up with plus and minus. Okay, so now let's simplify because we can just do some reducing, right? So we get, let's split them up one more time. We can split them up because they are over one number. Now let's reduce. So we get left with 3 and 2 and 1 and 2. And same thing over here, 3 and 2 and 1 and 2. So we get that x equals 3/2 plus the square root of 7 over 2, or x equals 3 minus the square root of 7 over 2. Okay, you can write them, I wrote them like that for a reason. You can write it like this, or you could have written 3 plus the square root of 7 over 2. Okay, you can either split them up, keep them split, or you can put them back together. Okay, I could have written this one like 3 over 2 minus the square root of 7 over 2. Either way is fine. Doesn't matter because it's all over one term. Okay. And that is the quadratic formula as a part of section 1.5.